Might as well have done it myself, I guess. So I think that P0 and Q0 are both draggable outside this loop. Yep. The center point of the circle is draggable, and if it is translated, then the Q point is being moved along. That would be this part. And Q is also draggable with a restriction lob down here that keeps it on the circle. I think that's it. That is all. Well, then of course they still have to be drawn. So that would be here. We make a circle and a connector. That would be nice, probably. And from that I get a direction. Yeah, I could have done this myself. I don't know why I'm asking the AI. Bad habit. It's still not finished. Shall I just stop it? Like, never mind, I'll do this myself. I'm gonna do it myself. If I'm finished before the AI, then I'll stop it. Although maybe it already edited it, my file. It already edited the file. My God, what a big changes. Really? You have another point, the style, another style of 0.3, and we have a circle style. Okay, I guess we can't get around that. A draggable point on a circle around 0.2, which is hopefully called Q. No, it's calling it 0.3 centered coordinates. The radius is 10% of the X. At point. Yeah, we have a circle. It drags. Oh my god. That is fun. It just drags it along. Yeah, that's not the idea. No, 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 no. But yeah, funny. And I can't drag this. Oh, I can drag it. Sorry. Never mind. Okay, that works. I'm gonna drag it around. So now you do this still. This that direction should be kept. Oh no, no, no! It becomes smaller, smaller. No, I don't want it. Absolutely not. It's actually not that easy. Current bounding box. It's a bit on the small size, maybe. Yeah, I can work with it. Maybe not. Let's just make it bigger. Okay, if I want to convert this from pixels to center, we have to theoretically multiply it with a scale. I keep forgetting what scale is. You have to divide it by the scale. Yeah, should be okay. Oh. Arzazu. Circle radius. Okay, I have a circle, fixed circle radius, and then what is tapped in? So Right, not possible here. The title is Just Me Working. So yeah, what's going on? It's a good question. I think it compiled. Yeah, this is ridiculous. Apparently that thing doesn't want to move. But pretty sure that's not how it used to work. This is 0.3, huh? 3.3. It's being added. Keep 0.3 on the circle. So I need something like this. 4.2. Register draggable. 0.2. Yeah. Plot is the centered coordinate system. Plot P2 is 0.2 centered. I agree with that. And the pointer is centered point. I think so. So that should be okay, and it returns center point. Translation, new position minus plot P2. Plot P2 is now 0.2 centered. So that had to be captured. And then plot Q2 is 0.3 centered. I still also have to restrict it still. Yeah, I must admit it's kind of a lame way to do it, but you know, what was it? Q2, that is 0.3 centered here. 0.3 centered plus translation. So a little bit too much center here, I think. I think that now the type safety works. I might as well drop the centered extension, because, well, if you make a mistake, then it should not compile. Therefore, that's what I'm going to do. You can't subtract two points like here if they are not of the same coordinate system. Not sure that makes any change, really. Probably not. Yeah, it does. So no, it's no longer following the center point. It's just... Oh, actually that did. What's happening? Oh, huh? That's A little bit. Maybe just move it too fast or something. Yeah, yeah. Huh? No. Sometimes the direction changes. But yeah, that must be, I don't know, caused by this code here. So the 0.3 centered. This is another one. Make it a moving arrow that I'll be using add point. And this is calculations with apparently are to make it follow 0.2. I'll just delete this. This is still changing the direction. You have to do something like this, I think, in the restriction lambda of well, 0.3. Oh, here also happens something that should not happen, should not be happening. This is what we want. Get the direction. P0 is 0.2. And new position is, well, new position. And then both are centered. So this must be a centered direction. Small CS point. Why is this CS rectangle? And this is a moth. CS KR window CS. Cursor depends on where the thing lives. So my direction is Math CS direction. No, actually, that's the centered point. Just that. Yes, I'm using NVim, yeah. What is this doing here? Point 2 is outside the updated bounding box. All that. So it feels a bit strange because this is a restriction. But it's just wrong. I mean, sorry. This should be part of the restriction lambda of the draggable point 2. Can no longer drag it or what? No. Okay, so no, it doesn't want to go to this side. Yeah, that's something of the other test, so I don't want to negate, I guess. This is now, let's put it at, no, yeah, this is, what is it, 30 degrees? See, it totally changed the direction. How's that happening? And it's not on the circle either. The thing is drifting like an idiot. Okay, this is not working, right? It's just not working. I think I need to keep the direction outside, not recalculate the direction all the time, but just keep it outside and then it's fixed. I'm going to do a big rename. bit too much. No, wait a minute. So now I'm confused. Was this really that type? Was it not plot type? Yeah, it's a plot type, yeah. Did that wrong. No, this is no rocket science. So I want to have a direction defined outside the lambda here. Did I already take it out? I already took it out. It's gone here. And I lost it, or did I put it somewhere? I did not put it anywhere. Great. Oh, actually I did. Here it is. So you move that up till, let's say, yeah, some defaults. I don't know, where does that go? Here. Default direction. initial direction of, well, direction period. Well, no, well, call it D0. The 0 is important here. I might have more directions later on. So we have a center direction, which is a coordinate system centered, and the direction that we begin in is simply right. And then we can just use that here. And now if the center of the circle is moved, and I call that now P0, I think. No, it's called, sorry, that's P2. P0 and P1 are the corners of the rectangle. And these should be called plot. Seriously. There's a certain convention that I built over time. And then it's annoying that it suddenly changes. So you need something like P, some number, followed by centered, to become plot, probably. And then the same thing. Still centered. I think I should really get rid of the too many of these post fixes, because that's the whole reason that I did the type save stuff. You can now pick whatever you want because you can't make mistakes anymore. So it doesn't make much sense to put the type, part of the type, in the name of the variable. That made a lot of sense in the beginning, because then it was not part of the type. It was just some point, two doubles, x and y. And then you really need to know what the coordinate system is. But now the coordinate system is part of the type, so yeah, I can give it a name, whatever name I want, I think. For the same reason, I think I'm going to I'm using Arch Linux. Percentage S. Let's change this also into just circle radius, no centered. I got lost where I was editing. The styles, there's the AABB centered form, lambda, it describes what it's doing here. And then, oh yeah, here's what I want. So we define the centered point and the centered direction. And these are the plotted points, they are visible. And then this is a corner, so this is the top left corner, the rectangle, and this is the bottom right corner, the rectangle, and this is point inside the rectangle. And then this is the direction, of the x-axis. We do need a new coordinate system here. But this point 2 is the origin of that. Let's call it oh yeah, I don't know, the P2 coordinate system. In centered coordinates, of course. So the direction is in centered coordinates. A draggable point on a circle around P2. So I want to call this okay, let's circle radius as const. You can also move that up a bit. Yeah. So you can, by dragging something on this circle, you can control the direction d0. And I should not call it d0 because it belongs to P2. So I'm gonna rename that to d2. I think so. D0 becomes d2. And then P3 should be renamed to Q2, I think, because that's what I do. So the center is called P2, then a point that rotates around the P2 is called Q. So all P3s should become Q2, which will probably also do that file wide. A point, that is then, I guess, at this position. Yeah, well, the points have to be added to the centered coordinate system in order to make them visible and to make them behave correctly, because they're all in centered coordinates. Centered is just a name. It just means that the origin of the centered coordinate system is in the middle of my window. That's why it's called centered, in the center of the window. So I add them. And then we make them draggable. So the two corners of the rectangle are draggable. And then we make the center of the circle draggable. And that is special because if we drag that one, then we want to move Q2 along. And this is already doing that, but apparently there's a huge floating point around off problem here. So instead of moving it to plot 2 plus some translation, I'm just going to use D2, the direction. And then we can do that exactly the same as above. That was somewhere I multiplied with D2 then, I suppose. Yeah. So we want Q2 to use that position at all times. So if P2 moves, then we want to move it to there. Translation, who cares? And then, of course, if Q2 is moved, it's also draggable. Then we want to restrict it to the circle, but D2 must be updated. So this part updates D2. I don't want to negate. That is something else. If it is less, then that's also not necessary, actually. No. I want to update D2. And then from wherever Qt is dragged to. But you also want to update Q2. But that Q2 is in the end put to the center point that's being returned here. So as soon as we have calculated D2, it is again that. That's the exact same thing as this. That's where it is, if D2 is known. So what you really want to do here is calculate the direction, the new direction rather. And what we have is the new position and the old position of Q2. That is the old position. So we need to create a direction from 2 points. You can just do that, I think. So this is a centered direction. And we create a direction from 2 points, and I think it's from 2. So the arrow points from Q2 to the new place. New being new position, right? Sure. And that would only go wrong if you move the mouse so fast that the new position is exactly in the center of this, on top of the. That is not. Sorry, that's not a Q2. Not P2. If you move the point on the circle on top of the center of the circle, then you don't know which direction that is then. So then this will a core dump or something. I'm not going to safeguard. Not going to safeguard that. I mean, I guess the best solution would be to, if that happens, then we just keep the old direction and don't change D2. Yeah. I think this works. Let's see, so it moves along, and now of course it's definitely not changing, because whatever I do here, the direction stays exactly to the right. And I can drag this also, and I can put it to the other side. You can do all around now. And you can put it somewhere, and then obviously it's going to move along again. Yeah. Now it's good. And then like this. Yeah, that was to be expected. Interesting. Interesting. So that lambda is not being called then. We do restrict. I think if this thing is being moved like this, I should actually, I think if you use move to, then it should work. Move to, do I want that? Okay, I can just use the normal restriction. See, I think the whole, this code is not good because here it has in the animation loop I'll say this updates the rectangle as a result of P0 and or P1 being moved, and then as a result of P1 and P0 being moved, P2 must go there, but that's just, you know, completely separate from my library. It just calculates where it should go to. And then if it is not where it is at the moment, then I move it. But I don't really move it actually, I'm just adding it again. So maybe I should move it here. Let me think, how can we do that? What about, I'd simply call move to restricted P2. This is not needed. Don't you love it when the API comes together? I mean, assuming it compiles and works. But this is simpler, nicer, more intuitive, and if it works, then oh yeah. Okay, that still works, this still works, this still works. You can move it outside, and then the last test. No, it takes it along. Oh yeah. The victory of my long hard work. That worked. Good. Uh-oh. To's outside the updated binding links. Needed. This comment is a bit silly. I think that should be moved in front of that. Let's do this immediately after creating the coordinate system. I don't know. And then the AI added a few headers, which is silly, I think. Do we need plot circle? Off direction, yeah, I'm using it. This I really don't understand. Oh, it added that for the standard oh god. What was it again? I've got. But I deleted that. We don't need that. I mean, circle. Well, I'm not even using circle. I'm using create circle. Just something entirely different. And that comes with the centered coordinate system, which already worked. This is this header here. No circle. Yeah, plot point is different, I think, because I'm actually having plot CS here. They're using it. And it probably the header is also not needed, because you can also do create point and you get the same handle. But okay, it is being used. A rectangle, I don't think I use a rectangle. Am I using a rectangle? Rectangle, draw rectangle style. Okay, maybe for the style I need a header. That's possible, but it's the exact same header as the rectangle. So if I don't need a rectangle, then I wouldn't need it. Okay, rectangle is literally being used here. Let's include that then. Here as well. No compile error. Yeah, no compile error. Yeah, let's not ask AI anything, because it's just not performing very well. So the next thing then is I want to draw a line through the circle in that direction. That seems easy enough. So we have the rectangle, we have the circle. No, maybe not directly. And yeah, no, sorry, man. Never mind. I do want to have a line. The comment: draw a line through P0 and Q2. Sorry, P0, P2, and Q2. Which then must be a plot thing, otherwise we don't see it. So it's a plot line, and maybe something more special there. Also in centered coordinates. And then we have to pass arguments that from which I can construct my line, which is probably the point that it has to go to, which is the center of my circle. And well, another point on the line, for example, or the direction, that would also work. Let's just use the direction, D2. It should work. Except that I don't have a line style yet. Or do I? You have point styles. You have a line style for the circle. Tangle style. Looks like a line style. Is this? It's not it. Here's the style. It derives from a line. It derives from line style. And it adds nothing. That should use something purple-ish. Violet, but a bit too purplish. Magenta, it's not a light magenta. Dark orchid. Fuchsia. Sorry, fuchsia. I don't know. Gotta pick something. Control T. Let's see if this works. Oops, I forgot to remove the space. And there's our line. Is that a 1 pixel width? Looks damn thick to me, but okay. Anyway, we have a line, and then everything moves along. And even that works. Very good, very good. Yes, with one line of code, very simple. Draw a line in centered coordinates on layer using this line style through P2 in the direction D2, and you get everything, including automatic dragging, rotating, moving. If you make the square smaller, it's beautiful. I'm gonna call this one actually the x-axis. But it is the x-axis of yeah. No, it's not really an x-axis. Let's call it line 0 then. And then another line, and this line must be drawn perpendicular to the previous one. Oh no! Well, we have D, and we want to make it, I don't know, rotate it 90 degrees, like that. Is that clockwise or anti-clockwise, or does it not matter? Well, it actually does matter, of course, but not for a line, I guess. Extends both ways anyway. Typical. And now you want to calculate the intersection points, 4 intersection points between these two lines and the bounding box. How many lines of code is that going to be? I think 2 lines, but I'm not sure. Definitely not as easy. Calculate intersection points of line 0 and line 1 with the rectangle. Yeah, it's going to be more than 2 lines, because you have to convert things to hyper blocks and planes. I'm doing this in n dimensions for some reason. So we have a hyper block. So it doesn't get a color. Why not? Is it one word? It's one word. I have a hyperblock for my rectangle. How do you create a hyperblock? Where's the hyperblock defined anyway? Hyperblock is defined here in namespace math. So let's begin with that. That is a math hyperblock. And it takes an n, that is the number of dimensions. So this is a rectangle, so that is 2. Making it a real rectangle. Now the hyperblock itself is not coordinate system aware. So yeah, I could make it coordinate system aware. I say I'm getting seriously tired of making everything coordinate system aware. So hyperblock is just not. Hyperblock has to be created though from 2 vectors by the looks of it, pointing at vector type is just a math vector. So we need a math vector 2 for 2 corners. And we know that the corners are plot P0 and plot P1. Those are 2 corners. But they are, I can't type anymore. They are coordinate system type safe, so you can't just pass them like this. Because this would, if we could pass it here, then they would automatically give up their coordinate, which coordinate system they are part of. That is not a good thing, not allowed. So let's have another look at where these things are defined, and they are defined here, and they are a plot CS point. And we find that back, that would be not here, but that's a draw point. I think here, yeah, here. and it is derived from a math CS point, but that is a CS point still. So this is just wrapping the draw point here. But you can treat it as if it was a math CS point. Let's go there, math point. Here is the math point. In paste math. That's not it. Here, this is the one. And that is a wrapper around the math point, and this is what you need. So we need access to raw, because raw is without the coordinate system. Which means that we have to call raw on it. Being very explicit about the fact that we want to drop the coordinate system. Safety. Okay, and I've got where it was. Hyperblock here. So call draw on it, and raw on it, I mean, and then again. And that should create a hyperblock of 2 dimensions, aka a rectangle without the knowledge of the coordinate system. Then we also need to create a hyperplane, which is 1 dimension less because it's a plane. I mean, that's the hyperplane means 1 dimension less than the space that it lives in. It's going to live in the hyperblock thing, so it's a line. You would almost say I need to pass 2, because then that's the space where it lives in, and then it's going to be 1 dimension less than that. But I think that I just have to pass 1 really. And here is let's see. N minus 1 dimensional hyperplane orthogonal to a given normal vector n. Do I pass 1 or 2 now? I'm not even sure about it. I think the normal is, yeah, the vector type here is the normal. That is 2-dimensional. That is just, in our case, that points somewhere. Well, that's the direction of the D2 direction, right? And vector type has n as dimension, so I should pass 2. Yeah, interesting. And then we have to pass the constructor thing. This is the only constructor, so we have to pass the normal of the line and a scalar type. See if I understand this. The hyperplane satisfies the normal dot product with some x plus b equals 0, where b is a minus n times minus the normal dot product with p, where p is on the plane. I think p is not only on the plane; it's going to be part of the hyperplane. Oh, that's why it's called plane. I was thinking I read plane, so I was thinking about a rectangle. Plane of hyperplane, so it's on the line. So we need a point P on the line, and then we can construct it by passing the normal, and this is the second argument. So the most important thing here is to get the normal. And that is a math vector 2. Normal is something, and then this is a line, and we can construct a line from the normal and minus the normal dot a point on the line, which is obviously going to be the center of my circle. which is P2. And the normal, well, the normal depends on which line 0 or line 1. Let's call this one then line 0. I have another one, this is the line 1. Then we also have two normals, normal 0 and normal 1. And then a normal 0 does the direction D2, but then the normal of that. I'm pretty sure I have a normal on the direction. And the normal 1 is, well, the normal of this direction. Yeah, why not? Rotated 90 degrees, that's the other one. Dot normal. Or we can read the direction from these lines. This maybe makes more sense. So this here created a line. It says auto, but I think it's a line of some sort. And the line, to find back the line, it just must be the math line. Draw line, plot line, math line. And then we go to the operators. Do we have that's not much. Oh yeah, well, just point in a direction. So I can call the direction here on it, on the line itself. I can get back the direction that this thing was constructed with, which is another class. Kind of makes sense that it would be called direction. To the direction on the line. Becomes a tiny little bit more symmetrical. Of course, here we just call it on the other line then. But yeah, this direction is going to be that. So it's basically the same thing. Let's see if this compiles. Doesn't error. No matching function. Roll call to math hyperblock. Brace and closed initializer list. Cannot construct a hyperblock from two raw points. Oh, well, it's two vector types. Thought raw was that type. Oh, it's a point. I'm trying to pass a point, and it wants a vector. Yeah, of course, a raw. But this is a point, and then you call raw on it, you get a point. So we have to convert a point to a vector. I think that's an explicit constructor. Hmm. Point. What point was it? That's a plot point is. But okay, that is just going to be derived from the math.cs point again. You might well continue to the math.cs point here. That thing does not have an. It has an automatic conversion to a translation vector. Yeah, that is still CS. Let's forget about that one. I just called raw on it, and then we have a not CS point, so I should go back and then go to the non-CS math point. Here. And then there's an ops or data. Data has, you can get the eigentype. It's maybe not useful, but it's about the only thing we have here. And ops has nope. Doesn't even mention vector type. So it is not supported by point itself. But maybe you can construct a vector from a point. I think yeah, definitely, right? Right. So I'm gonna go to the math vector. Math vector here. And then the constructors. We can construct it from 2 points or explicitly from 1 point. This is what we need. And it must be explicit, so we have to use the vector type around it. I don't like the view of it. Looks a bit messy like this. And now here is a problem. There's no normal. Oh, direction has no normal. It's a new one. It must also be line ops direction. That's not. Wait a minute. I wanted to go to direction. And you must go to math direction. Did I go past it? I did go past it. Curve direction, draw math direction, and again too far. Yeah. And I've got what I need from it. Oh yeah, normal. Don't have a normal, we only have this. Oh well, just have to live with it. And then, of course, we have no conversion from it's still a CS now. Because this was a CS. So we could call raw somewhere. Might as well call it at the end, I suppose. Cannot convert. Still CS. Is that further along the line? 2 month vector, again raw. Raw is again required. Maybe if we call it raw on the P0, P1 and P2. Maybe we should call raw here already. Just switch to a non-coordinate system. Version before doing stuff. No, not. Oh, wait a minute. It's still the problem is still here. Cannot convert math point. Oh, it's again a point. Oh my god. Yeah, by now I'm gonna make extra lines. You think this will compile? I don't know. No, I don't think so. Maybe. Nah. No, it doesn't. No, it doesn't. I'm trying it anyway, but it doesn't. Really not compiling. Or no. So we have to really explicitly say we want to drop the coordinate system stuff. No, now we have to calculate the intersection points between those, because this is finally supporting it. We have a hyperblock intersection points with hyperplane. And that returns intersection points. So hyperblock intersection points. Returns hyperblock intersection points. Let's first pass my planes. So line 0. Calculate intersection points with between line 0 and line 1. And the result are intersection points. Intersection points 0. Where intersection points is a vector of intersection point, which is a wrapper around a math vector and an edge index. Because that tells us which edge it is. Not sure if I'm interested in that. I think explicitly not interested in that, because the information is lost at some point. So we are only interested in this type, and we get that by calling, well, just assigning it. It's an automatic conversion to that type. Shall I just work with arrays, or shall I keep track of, well, at the very least, which line it is? I'm not sure. Let's keep track of it for now. So let's sort this in an array. Size 2. Section points. These are also intersection points though. Oh, this is a vector. Why would they turn a vector into an array? Never mind. So let's add a point. Let's show all the points. So we have in that coordinate system, add point. Add point. I don't want to add point. Let's create a point. Layer. Yeah, I don't know. Some intersection point style. Intersection point style. And then I think they're just the arguments of the constructor of the point. Create point. This is coordinate mapper. Should be the one, yeah. Takes a point, yes. How to convert it back first. as well. But yeah, I just have to pass the point. So we need this, where this is CSID centered. It's 2, but well. Maybe put all the other stuff in an array as well. So if like a lot of lines are double. So we need an IP style now, where it is a point style. I don't know, keep using those 10 here. What is that even? Field shape. No comment where I can find what the 10 means. Yeah, here it is. 10 is an ellipse. Let's use cross. I'm gonna use a cross. 4. No, what? 5, sorry. Does this still compile? No, of course not. No match for operator square brackets. Operator types are utils vector. Oh, it's a utils vector. Yeah, that's the whole point of it. It's more complicated than that, they say. This type here, this IPS, is not a normal vector. It's whatever this is returning, which was an intersection points, which is a utils vector that uses intersection points index as index, which is defined here as part of the hyperblock type. Yeah, so basically we don't want to have an I at all. But then again, my IPS, sorry, this is. I should do auto something. IP0 from IPS 0. So run over all intersection points in intersection points 0. And then we can just use IP0 here. Same thing here. Oh. Now what? No matching function for call to CS point math centered braced. Cannot construct a centered thing from IP0 because IP0 is doesn't tell us. Oh yeah, node candidate 1. Candidate 1 takes a math point. I thought it was a math point. Apparently not. No known conversion from argument for argument 1 from intersection point 2 to math point. What is an intersection point then? You also have a special type for an intersection point. You got to be kidding me. Oh, of course, the number of dimensions is still in play here. Okay, so this gives us apparently intersection points. And we need something else. We need a vector type, the underlying vector type. But it was an automatic conversion. Okay, but it doesn't kick in because it doesn't kick in. So I have to be more explicit about it. Let's try to static cast it. It should be a math vector too. I don't know why this is not being used really. A tiny little bit lame here. So we need a vector 2 still. And I'm going to call that IP. And I construct it explicitly from the IP0. That should work. And if not, then we get a better compile error now. No matching function still. Matching function call to math CS point centered from the whatever that is. IP. Well, I just defined it because it is a CS and that's explicit. Yeah, I have to convert it to the centered. Sorry, that was the problem to begin with. I think we need a real point here. So a math CS vector. CSID centered. Which, let's see, vector CS math CS vector. You would almost use this. Almost. It can be constructed explicitly from a math vector 2. So no, still we need a math vector 2. And I bet that it's not going to use the automatic conversion. Because on one hand this one wants to be explicit and the other one is then an automatic conversion. So yeah, that's not going to compile this. But let's try it anyway. Shocked. This does compile. How then does this not compile? So I don't want a vector here. I don't want a vector. I want a point. So the vector might work. But now I need a point. This stupid juggling between vectors and points is ridiculous. I mean, it strongly hints at that hyperblock and hyperplane should be working with points instead of vectors. Or both. Warning, ignoring return value. Oh, I'm creating... Duh. Yeah. This returns point handles, so we have to keep them. You could store it in an array, but then we need an index again. Can't really do that then. For example, static standard array point handle. Point handle is defined here. It's not very useful, maybe. Coordinate mapper, nah. I'm just gonna use this type directly. And it should be always 2. Or I could use a vector. And then just add them to that. It's maybe not such a bad idea. I think that's a better idea even. Yep, we passed it. Okay, I'm gonna wrap everything here in an array, standard array, math vector 2 normal. For int L of line. 0 L is less than or equal 1 plus L. Do this. Where now the math vector normal is actually just normal L. And then we need the line. To the line itself must also be an array now. So here we have a standard array with auto. Oh, great. Great. We don't know the type. Yeah, I do, but it's create line. Yeah, it's again a handle. So it's going to be the same thing as here. Well, plot something. Plot, yes. Line. centered, comma 2. Plot lines, get it centered. And then we loop again over the 2 lines, and then we store. This is now plot lines. Plot lines L. Perpendicular to that. Standard array, math hyperplane, comma 2 lines, is you can default construct a hyperplane, I think, and then assign to it. No, we cannot. Could change that, but let's not do that. So we have to construct them in place. Hopefully this works then. Which means we can't use a loop. I just have to list them like that. Although here this is then of course normal 0 and normal 1. And here we have an auto again. Great. Standard array. Nobody knows the type. That was a difficult type, wasn't it? The intersection points. So hyperblock intersection points, not that difficult. Comma 2 by PS. Or this is an 2. And the hyperblock is the same thing as here. That is a math hyperblock. And we can loop again. Boy. I think we need extra braces here. It's not I, it's L. Yeah, it compiles. So I tested already. It compiles and it works, as you understand. Compiling is the same as working. Okay, so yeah, now we have our intersection points. It's just to follow the rectangle. Mm-hmm. How cute. Gonna improve this because it didn't. I mean, we had just 2 lines which looked very much the same, and then I replaced them with 2 lines that doesn't make anything more easier. However, I think now we can move stuff like plot IPS. It's used there, but I might as well move it up. So I'm gonna move it up. And here we have another one that can be moved up. All of this. Oh, this is using normal. Yeah, that sucks. Because I couldn't put it in a... I could not put this in a loop. So we consider this to be a loop for now. Then we just move this up. And then we move all of this up. The comment actually goes to the... Well, even there. What? Intersection points, calculate intersection points. And then this can be moved above there. I really need to put this into a loop. Okay, let's see if it still compiles now. What's it? My editor did play up a little bit. Okay, still okay. Okay, we can make it a vector, I guess. Let's make it a vector. Then I can do a default constructor. Or not. Can we make a default constructor? Probably not. Now I think about it. So lines vector. Classes without default constructors, they really get in the way. So maybe I should just add a default constructor to the hyperblock. Oh, this compiles. Huh? It's still strange though. So next you're gonna tell me that array also works? I thought hyperplane had no default constructor. I think it's a vector thing. Yeah, see, wrong number of... probably vector thing. I don't think this compiles. No. Deleted array. But we can make a vector. We can make a vector of stuff that does not have default constructors. It's good to know. Well, basically logical, so I should have already have known that. I knew that probably, and then I forgot it. Okay, so yeah, vector, and then this is going to be put in a loop now. Where we assign to no, not assign. I'm gonna do and place back. Place back the calculated value for that line. See, the thing still works, right? Of course it works, because it compiled. What was I thinking? And then, my friends, you can move this one up. And then you can combine everything in one loop, because the lines are not dependent. Like that. And then with a lot of eye squinting, you could call this better than the other code, because there's less repetition in it. Not so sure about well. And then you could combine all the arrays as well, but not really need for that, I suppose. And why would you? And you can put everything in the scope. So all this junk that was declared there is just temporary now. everything, these can be const, of course, and the array are going to assign to. Those as well, and this one as well, so they cannot be const. And this was maybe laziness. What is the type of IP? That is whatever is returned by IPS, which is what is returned by intersection points. So that is what is returned from here, which is a detail intersection point. Well, it's in detail, so probably should not use that type. Let's keep it auto. But I think I know what it is. It is an just a L value type. So this is you can use auto ampersand in a loop like this if you have no idea what for type it is. That's just the best thing, and you get the best the least CPU overhead. So in fact, it's kind of a magical type that gives you this is always good. So if I don't know what the type is, I use auto ampersand, but it's we just pick it, and it is a detail something, but what you really want is just a const reference to it. So we know it's a reference. Auto is never a reference. So this is the detail hyper, what was it? And the intersection point struct or whatever. And then we get a reference to that, probably. And we don't change it. Just making a copy over here. Yeah, just too bad that it is a vector for some reason. Can only convert it back to this vector. And then from there we have to call add point, s point to make it a point again in order to convert it to the final thing. Oh, wait a minute, I don't need a cast anymore, right? S point is just this type. I'm happy with that simplification. Okay, now I think I'm going to bed. What is just got my mind ready for it. What is the next thing that I wanted to do? It's like this. I want a rectangle that is aligned with this coordinate system here. Well, yeah, it kind of is, right? The purple one, the fuchsia one. And then draw a rectangle that goes through all these points. So there's only one rectangle possible, right? This rectangle, so like that. I want to draw that rectangle. So I think I need to turn these two lines into a coordinate system. So from these points we should derive a translation and a rotation. No need to scale it, I suppose. And then convert all those points to that coordinate system, and then we can just get the width and the height. Yeah, maybe not, I don't know. In the end, we're going to end up with a rectangle here. And then the question is there a method to convert that rectangle, if you have that rectangle, we have the rectangle and we have those points. Is there an algorithm that can convert this rectangle to a finite rectangle that always contains the big rectangle here, the original rectangle? So in this case, you have to grow this line here until it touches there. Yeah? So then that must be something parallel to this line, which goes through this point. So that rectangle would be a line like this, and then a line like this, touching this point, and then a line like this, parallel to here, touching that point, and then like that. So that big. I think that it is gonna be big, the biggest, as it were, if this angle is 45 degrees, but never infinite. I mean, it doesn't matter where you put this thing, for example. There is always the same 45 degrees rotated rectangle here, like that. That contains this one. Whether you put it here or there, it's the same. It's going to be the same thing that contains it. However, there's one problem. We don't know where the corners are. And you cannot conclude that in this situation, because we only have information about, if you only have those 4 points here, this rectangle could be infinitely long to the left and to the right. So you just don't know. Even in this case, where you cut this one, this one, this one, and this one, you only have those 3 lines. So this line could still be arbitrary far to the right, and thus also these corners. So that would still require an infinitely large rectangle to be sure that you can include those corners here. But yeah, then I thought I can assume that there is a maximum aspect ratio that we live with, say. So this thing can never be more than twice as long as high. And in that case, as you can see, we can cross it here, so this one and that one, and then not cross this and this. But you cannot do it the other way around, because this is the long side. That's why we can have 2 here and 2 there. You cannot cross that one and that one. Also not if I rotate it. Just this is the worst case scenario anyway. So we can put both of them here. But then obviously these two never cross that. Unless you would put it super close and then rotate this thing so that, well, at least one point is going there. But never two, because now this one is going to be close to that one. So for example, in this case, you would have no information about the top. Oh, actually, that is a problem. So maybe you cannot have only information about this one and that one because they are the shortest, but you can have information about three of them, but not alongside. It's not guaranteed that you always cross both long sides. You cross always one long side. Now you cross both, and now you cross one again. It's not possible to cross 0 long sides. But okay, so back to the case where we don't cross, say, the bottom. And then you don't know what is the long side, because this thing now could be arbitrarily far to the bottom. So it could be that this is the short side and this is the long side. You know this distance, and then times 2. So then the maximum point of the maximum height where this bottom line is this distance twice below the top. So it's off my screen. But, yeah, do it like this. Put this height down, it's here, and then again, it's here. Down here. So then it's possible to draw a rectangle that touches this corner. Like have a line like this, like this, like this, and then like this. Definitely a finite thing, no matter how you rotate it. So I want to calculate that and then move this around. Rotate, move it around, and see how that thing moves. See that it always includes it and that it doesn't arbitrarily far blow up, no matter where I put it. And then we have a visual confirmation for the correct algorithm. And it's a nice test for my library. Of course, right? Totally. I've been doing cool things already. Making this. Okay, I'm going to bed. Good night.